Welcome to Practical Statistics for Nursing using SPSS. This video shows how to process the ANCOVA test. You can watch the entire video or use the time slider to navigate directly to any time point. The ANCOVA test is similar to the ANOVA test. Before proceeding, it's recommended that you first view the video ch06 anova.mp4. In terms of setup and results, the ANCOVA test and the ANOVA test are quite similar. Remember that the ANOVA test assesses 3 or more groups to detect statistically significant differences between the pairs of groups. Specifically, the results of the ANOVA test are based on the effect that the independent variable, the antihypertensive drug, had on the dependent variable, systolic blood pressure. The ANCOVA statistic allows us to include a potentially confounding variable into the model, which we expect may influence the dependent variable, such as smoking rate. The ANCOVA test then adjusts the results in the dependent variable accordingly. The ANCOVA test has 2 pre-test criteria: homogeneity of regression slopes and homogeneity of variance, Levene's test. We'll check for homogeneity of regression slopes now. We'll see the results of the homogeneity of variance test when we run the ANOVA test. This example uses the dataset ch07 example01 ancova.sav. This dataset contains 3 variables. Group is a categorical variable containing 3 values: drug A, drug B, and drug C. Systolic BP is a continuous variable that contains the systolic blood pressure of each participant at the conclusion of the study. And smoking is a continuous variable that contains the mean number of cigarettes that each participant smoked on a daily basis. To check for the homogeneity of regression slopes, click on Analyze, General Linear Model, Univariate. Move Group to Fixed Factors. Move Systolic BP to Dependent Variable. And move Smoking to Covariates. Click on Model. Select Custom. Move Group and Smoking to Model. Next, hold down the Shift key and click on Group and Smoking. This will select both Group and Smoking together to signify the interaction term, and move them to Model. Click Continue, click OK, and it'll process. We look to the Test Between Subjects Effects table. If the p-value for the group smoking interaction term is greater than 0.05, then this would indicate that there is no statistically significant difference in the regression slopes among the variables involved in this model. Hence, the assumption of homogeneity of regression slopes would be satisfied. In this case, the p-value is 0.028. Since this is less than or equal to 0.05, this indicates that there is a statistically significant difference between the regression slopes for systolic BP and smoking. This violation makes sense as the covariate is somewhat atypical. The covariate in this model is smoking, the number of cigarettes that each participant smokes in a typical day. Since more than 90% of the participants are non-smokers, this finding is not unexpected. Since this pretest criteria is not fully satisfied, this should be noted in the results section. To run the ANCOVA test, click on Analyze, General Linear Model, Univariate. Click on Model, select Full Factorial, click Continue, click Options, move Group to Display Means For, check the Compare Main Effects checkbox. In the Confidence Interval Adjustment pull-down menu, select Bonferroni. In the display options, check Homogeneity Tests. Click Continue, click OK, and it'll process. To finalize the pretest checklist, we see that the homogeneity of variance test produced a p-value of 0.791. Since this is greater than 0.05, this indicates that there is no statistically significant difference between the variances. Hence, this criteria is satisfied. Next, we look to the test of between subjects effects table. The p-value of 0.004 indicates that a statistically significant difference has been detected among the adjusted means for the groups. In the estimates table, we see the adjusted means for each group. These means have been adjusted to account for the smoking covariate. These figures will be useful when documenting the results. Finally, we look to the pairwise comparisons table. This table is read in the same way as the multiple comparisons table produced by the ANCOVA post hoc test. To identify the pairs of groups that are statistically significantly different from each other, we look for p-values that are less than or equal to 0.05. We see that there is a statistically significant difference in the adjusted means between drug A and drug B, and between drug A and drug C. This concludes this video.